Hello, ladies and gentlemen. Welcome to Chapter 12, and we are going to be talking about solutions. Not math solutions, not solutions to life problems, but solutions that are a homogeneous mixture made out of multiple substances. If you aren't sure what all that means, that's fine because we are going to describe what all of that means. Just realize for now it's a homogeneous mixture made out of multiple substances. Now, some of this you probably know and have heard before, some of it is probably new. So just remember what you knew and add to what you know. Okay, first off, when talking about a solution, let's talk about the parts. Okay, you probably know these terms of solvent and solute. However, the definitions might be a little bit different than what you're used to. Okay, the solvent is whatever substance is in the greater amount. In other words, whichever one has more of it in the solution. Okay, you probably had something along the lines of it'll dissolve the solute or it dissolves something. Okay, we're going to get a little past that, and it won't always be evident as to which is dissolving which when you're talking about some types of solution. So realize for a solvent, it's whatever has the greatest amount of something. Okay, so if there's 5 of A and there's 3 of B, A is the solvent. Okay, the solute is what gets dissolved into the solution. In other words, everything that is not the solvent. Okay, now we need some basic characteristics of solutions. Okay, first off, the word you may or may not have known, they are homogeneous. Okay, you can see the root word homo meaning same, and the gena meaning beginning or origins. In other words, it looks the same all the way through it if you're looking at it. Okay, it doesn't have layers, it doesn't have sections. It is the same throughout. You look at it and you can't tell the difference. Okay? The next characteristic, the term you might not know, is it is miscible. Miscible. In other words, it stays homogeneous. And by the way, it can be homogeneous or homogeneous. It doesn't really matter. Okay? That means it's not going to settle out. Okay, if you think about things like oil and water, if you mix them together, or vinegar and water, they eventually separate out. That is not a solution. If you have a fine mud where clay particles are floating in the water and eventually it settles out, that is not a solution. Those are what are called immiscible. I am miscible. They do not stay homogeneous. They settle out. Now, what's kind of hard to realize is that these particles that are dissolved cannot be filtered out. So if you have some sort of paper filter, air filter, whatever kind of filter, if it can be filtered out, it's not part of a solution. You cannot filter out the solutions. And these are not chemically combined substances. They stay separate. It's a physical combination. It's a mixture. It's just like if you take red M&Ms and you mix them with blue M&Ms. They stay red and blue M&Ms. They don't turn purple. Okay, so this is not a chemical combination. It is a physical combination. Now, when you're talking about solutions, there may be some things that you may not have thought of that are solutions. Okay, first off, you can have a gas dissolved in a gas. This would include our atmosphere. So when you think of our atmosphere, we usually think oxygen. But the reality is nitrogen is in much higher quantities than oxygen. You have carbon dioxide, carbon monoxide, ozone, hydrogen, helium, all different kinds of gases, and they're all mixed together. We don't use all of them when we breathe, but all those different substances are there, and they're not physically combined together, or they're not chemically combined together. They're just next to each other. It's a physical combination. Okay, secondly, a gas could be dissolved in a liquid. When you think about soda, all those bubbles are carbon dioxide that are dissolved in a liquid. Now, as long as that bottle stays closed, that carbon dioxide will stay dissolved into the liquid. It's only when the pressure changes, when you take the top off, that carbon dioxide can be removed, and that has to do with other things. Okay, so it is a solution of a gas dissolved in a liquid. You also could have a gas dissolved in a solid, things like all the different air bubbles and things that could be trapped in ice or foam, different things like that. Okay, so a gas can be dissolved in a gas, a liquid, or a solid, any of the three. Okay, solutions can be where you have a liquid dissolved in a gas. That would be an example of a foggy day. If you are familiar at all with living in most places, there are foggy days, not if you live in a desert, however. And what you have is little drops of water that are actually just hanging, suspended in the atmosphere, essentially like a cloud, except that it's down close to the ground. That is a liquid dissolved in a gas. You also can have a liquid dissolved in a liquid. This is giving the example of rubbing alcohol. It is 70% alcohol, 30% water. There are lots and lots of different things where you have a liquid dissolved in a liquid. Things like lemonade, etc. Okay, just lots and lots of things. Usually for our lives dissolved in water, but not always. Okay, now something that's rather rare is where you have a liquid dissolved in a solid. Really, the only time that you have a liquid dissolved in a solid is in the case of mercury, which is a liquid metal at room temperature. They have the ability to merge this mercury with other metals. It's called an amalgam. And what ends up happening is the mercury just kind of dissolves into this other metal and mixes with it. And it stays there combined with the other metal. Okay, so like I said, it's pretty rare. It's not something you normally encounter in daily life unless you have a lot of fillings in your teeth. But it is a situation that happens where a liquid is dissolved in a solid. Okay, liquids or solutions can also be where you have a solid dissolved in a liquid. We're pretty familiar with things like this, things like, salt water, sugar water. If you dissolve sugar in your tea or your lemonade, things like that. Or the ocean has the salt water combination. Okay, solids dissolved in a liquid. Now, you also can have a solid dissolved in a solid. And this is where you're going to have an alloy, which is a mixture of metals. Alloys are really the most common type of solid dissolved into a solid. And an example, as it shows, is bronze. This is an Olympic medal from 1980. It is just a mixture of tin and copper. Okay? The tin and copper atoms are not chemically combined, they are simply next to each other, and we call that bronze. Now, what you will notice is you don't have a solid dissolved in a gas. Okay? For some reason, even if you have a solid suspended in a gas, it is not considered dissolved in it. Okay, whether you think of something like smoke in the air or, snowflakes, for some reason it's not considered dissolved. Okay, probably because it's not necessarily on the atomic level. The particles are too big usually. Okay, so now that you know what solutions can be, you're going to learn all kinds of things about solutions. Until next time.